Hi, I am a tutor in Uplatz. Today we are going to discuss about most network service. The network service represents the standard protocol stack for most, and the commonly used term most network service is a trade name of the SMMC corporation where the most net services have to be licensed. The most specification uses the term network service, however, as a term which is independent of a product. As shown in figure 9.1, the network service is based on the network interface controller, NIC, or intelligent network interface controller, INIC, and provides programming interfaces for the application, which basically consists of the function blocks. It comprises modules for transferring packet data in the packet data channel and modules for controlling the network via control channel. That is, it contains mechanisms and routines for operating and managing the network, and it ensures dynamic behavior of the network. The network service is implemented on the external host controller. Control of the streaming data channels is also part of the network service. The transmission of streaming data, however, is not. Basic structure of the most net services, network interface controller, network services low level, NICR, INIC, network service layer 1, basic layer, network service layer 2, application socket, I protocol, layer 1 API, layer 2 API, IP API, F1, F block 1, F block 2, F block M, external host controller, EHC. Most NIST services, the most NIST services are a standard implementation of the network service provided by SMSC. They are tuned to the network interface controller, NIC or INIC. The most net services are divided into basic layer 1, and the application socket layer 2, and can contain additional modules such as most I protocol. Model of the most net services, YSA layer, physical data link, network transportation presentation application, NIC Wi-Fi, network interface controller, net service layer 1, 1.x basic level, net services layer 2, 1.x application socket, function block, INIC, Wi-Fi, E5, intelligent network interface controller, net services layer 1, 2.x, 3.6 Wi-Fi, net services layer 2, 2.x, 3.x application socket, function block. The most net services are written in ANSI and can be used directly for porting on different processor platforms. ESC, SMSC offers 4 license type: evaluation license, system license, product license, 2 license. Model of most net services, the NIC and the INIC have their own versions of the most net services. Layer 1, version 1.x for NIC, version 2.x and 3.x for INIC. Since the INIC covers the basic functions of layer 1 itself, and the most net services only have to provide an interface between layer 1 and layer 2. The most net services layer 2, 1.x and 2.x or 3.x only differ in the modules whose functionality is covered by the INIC. Dependence on the most specification baseline, the most net services version 1.x and 2.x have been designed according to most specification revision 2.x. Version 1.x is available for most 25 only, while version 2.x is suitable for most 25 and most 50. Version 3.x has been designed according to most specification revision 3.x and is available for most 50 and most 150. Modules of the most net services layer 1 version 1.x. The most net services layer 1 version 1.x have been designed for the NIC. The I2 CBus, the SPI or a parallel interface are available as interfaces. The software interface of the NIC consists of a set of registers which can be read and written by the microcontroller. This set of registers is referred to as a register wall. The modules of layer 1 are introduced. Figure 9.3 gives an overview of the module of layer 1.x. Most net services kernel, MNS, most net services kernel is the central entry point for all services of layer 1. It initializes all trigger and fallback function. Most supervision MSP, the most supervision MSP provides final state machine for the network management. The following functions are covered: initialization, determination whether The device is timing monster or timing slave. Configuration of the source port, network startup and shutdown, power management, error diagnosis, and error message generation. Self-test dependent source port configurations are supported. Network, most net services layer I version 1.x network interface controller, which is one low-level driver LLD, I2C, SPA parallel, control messages CMS service, application message service, asynchronous channel allocation service CS, asynchronous data transmission service ADS, most transceiver control service in CS, most supervisor in MSV, most net services kernel MNS, level 1 API. Control messages services, the control messages services sends and receives the control messages which are transmitted on the control channel. The services comprises the following functions: initialization, control message reception service, control message sending service, message buffering, error handling, and error message. Asynchronous data transmission service. The asynchronous data service is responsible for sending and receiving packet data and the packet data channel. The service comprises the following functions: initialization, buffered sending of packet data, buffered receiving of packet data, error handling, and error message. Application message service AMS. The application message service is based on the control message service and provides a transmission protocol for segmentation of longer applications messages which are transmitted on the control channel. It segments the message into 70-byte blocks in the center and resembles the message for these blocks in the receiver. The service provides the following functions: initialization, sending application messages, receiving application buffering messages, error handling, and error messages. Synchronous connection service SCS. The synchronous connection service controls the routing engine are reintegrated into the NIC. It provides the necessary functions for allocating and placing streaming data channels and for configuring the streaming data source and sync. Following are the functions in detail: channel allocation, allocation and routing, deallocation and routing, disconnect, source connect, source disconnect, sync connect, sync disconnect, direct channel by label. Most transceiver control services, MCS, the transceiver control services enables application specific initialization of the NICs. By means of this service, all the relevant parameters can be set. The following functions are available: setting up the address registers in the NIC, access to important NIC registers via the register access API, setting up the RMC capability, timing master function, selection of the frequency source, setting of the boundary descriptor. Further information can be found in the most specification in the basic service, layer 1 programmers, library documentation, MNS L1 1.x, and in the most NES services, layer 1, example MNS L1 EXA. Layer 1 version 2.x and 3.x, the most NES services version 2.x and 3.x of layer 1 are based on the INIC, which integrates kernel functionality of layer 1, administration of letter status, transfer device check, the driver call message, reception and dispatch, control of the routing engine. The most NES services thus only have to provide buffers for the data handling and the API known from version 1.6. The modules of the NET services are also referred as wrappers. Access to the INIC is no longer affected via a register wall, but via an integrated F block based on the messages. This different type of access is more abstracted by the wrapper module. The layer 1 API remains mostly unchanged. Most NET services layer 1 version 2.x, intelligent network interface controller, most NET services mini kernel, F block on chip, INIC, minimum net block, INIC message interface, low level driver LLD, control port media LP, port message service, PMS, message interface service, MAS, application service, message service wrapper, WAMS, control message service wrapper, WCMS, asynchronous data service wrapper, WADS, virtual most supervisor VMSV, most processor control wrapper, WMCS, socket connection manager wrapper, WSCM, message buffer management in VM, most net services kernel MNS. The interface for most control messages as well as administrative communication between net services and the INIC is control port, which is physical address via I2C or media LB port. A further interface is used to provide access to packet data channel. This interface can be physically addressed via I2C media LB are in version 3.x also via SPI. Figure 9.4 shows the structure of the most MS services version 0.x. Figure 9.5 illustrates the structure of the version 3.x. Auxiliary to the new SPI interface, the control message services WCMS was eliminated and the most debug message module MDM was newly introduced. Most net services kernel MNS, most net services kernel MNS is an version 1.x on the central entry point for all services of layer 1. It initializes all trigger and callback functions. Virtual mode supervisor VMSV, the virtual mode supervisor VMSV provides user with the mapping of the actual supervisor implemented with the INIC. The functionality is similar to version 1.6 in comparison to version 2.x and version 2.x provides enhanced network diagnostic functions. Most net services layer version 3.x, intelligent network interface controller, most net services mini kernel, block on chip INIC minimum network block INIC message interface, low level driver LLD, example I2C media LB SPI, port message service PMS, message interface service MAS, application message service wrapper WAMS, asynchronous data service wrapper WADS, virtual most supervisor VMSV, most processor control wrapper WMCS, socket connection manager wrapper WSCM, most debug message module MDM, message buffer management MBM, most services kernel MNS. Wrapper modules, the wrapper modules control message service wrapper WCMS, application service wrapper WAMS, most processor control service wrapper WMCS, asynchronous data service wrapper WADS, basically map the API of version 1.x onto the functions of the INIC. Only the API of the socket connection manager wrapper WSCM deviates considerably from the SCS API because the administration of streaming channels now runs directly via socket and no longer via the direct programming of the routing engine. The control message service wrapper applies for version 2.x only. In version 3.x, it is substituted by the application message service wrapper WAMS. In comparison to version 2.x, the socket connection manager wrapper WSCM of the version 3.x also provides interfaces and configuration for accessing isochronous data channel and new interfaces. Example, TSA transport stream interface for video obligations. Data handling to the INIC, the interface between the INIC and the most net services uses a port message control protocol. The modules, message interface services, MAS, message buffer management MBM, and post message services PMS. Control this protocol, buffer the messages, and supervise the different repos in the INIC. Further information can be found in the most net services layer 1 wrapper for INIC, user manual specification, MNS L1 2.x or MNS L1 3.x. Most debug message module MDM, most debug messages are messages that are reported on the most control channel suitable to signal and device or system related debug information. Such messages are not received by any other device, but they can be recorded by system analysis tools. The most debug message module controls the protocol and provides transmission services for such events. It is available in version 3.x only. Most net services layer 2, network interface controller, most net services layer 1, most command interpreter CMD, F block enhance testable DET, net block NB, NetworkMaster shadow, address handler and decentralized device register AH, most supervisor layer 2 MSV2, notification service in TFS, most services kernel layer 2 MNS2. Layer 2 version 1.x, 2.x, and 3.x, the most net services layer 2 builds on the most net services layer 1. They provide the API for the application specific function blocks. The system function blocks, such as the net block, are however part of the most net services, since the implementation of the function block enhance testability is application specific. The most net service only contains a skeleton. The modules which differ in version 1.x and 2.x will be referred to as in the corresponding sections. Figure 9.6 shows the structure of layer 2. Most net services kernel layer 2, MNS2, as in layer 1, most net services kernel MNS2 is the central entry point for all services in layer 2. It initializes our trigger and callback functions. Most supervisor layer 2, MSV2, most supervisor layer 2, MSV2 also provides finite state machine for managing the network state on the application level. Example, communication permitted, not permitted. The following functions are implemented: address initialization, configuration on the application level after the init ready event in the network slave, initialization of the central registry in the network master, network change event, NEC supervision. Table of the available FBlocks and FBlock shadows. FBlock ID, pointer or instant ID stored in RAM, pointer and function table stored in ROM. NetBlock 0 and function NetBlock, FBlock 1 and NetBlock.pf NetBlock IDs, instant ID 0 and function FBlock 1. FBlock 2 and NetBlock.pf FBlock ID dot instant ID 1 and function FBlock 2. FBlock N and NetBlock.FBlock IDs dot instant ID n-1 and FBlock function FBlock N. FBlock shadow 1 and instant ID shadow 0 and function FBlock shadow 1. FBlock shadow 2 and instant ID shadow 1 and function FBlock shadow 2. FBlock shadow M and instant ID shadow m-1 and function FBlock shadow M. Command interpreter CMD, the command interpreter module is used for table control the decoding of received control messages and for automatically calling the handle functions of the blocks defined by the user. The decoding table contains all implemented FBlocks and FBlock shadows. It basically has the structure shown in table 9.1 and can be easily extended. The table of the available FBlocks and the function tables can be stored in the ROM as the instance ID can be changed during runtime. The table containing these IDs must be stored in RAM. Second column during initialization, it is filled with default values. The third column contains the entry access of the related function. Notification service NTFS. The notification service is used for automatically sending the status messages to other devices when the properties of an implemented FBlock change. This mechanism was already introduced in section 4.2.2. Table 9.2 shows the notification matrix array and FBlock. The matrix must be available for each FBlock supporting notification service. Property 1, FBlock X, property 0, 1, 2, 3, n-1, black field 0, 1, 2, 3, n-1, entry 0, 0.1, 1.1, 1.2, n-1.1. FBlock X, property 0, 1, 2, 3, 4, n-1, entry 0.2, 0.2, 2.2, 0.3, 1.2, 0.m, 1.m, 2.m, n-m. The notification matrix of FBlock X, MNS L2, N, the number of properties of FBlock support notification is M, maximum number of devices able to subscribe to the properly. The term entry in the table is an index in the device table which stores the logical group addresses of the devices that have subscribed to the properties. Address handler AH is based on a state machine. It transforms symbolic addresses into memory location and manages a decentral registry in the slave, similar to other modules of layer 2, closely cooperate with application message service AMS. The controller does not necessarily have to know which device implements an FBlock. It suffices if the FBlock ID and the instant ID are known. The wildcard 0xFF is entered into the target address field of the control message. If the address handler AH receives a message with this wildcard, it first searches the FBlock ID with the related instant ID in the least central registry in the standard configuration as shown in figure 9.7. If it finds the FBlock, it replaces the target address field with the real target address. Such fields it inquires by means of the NetworkMaster shadow module about the FBlock at the central registry located in the NetworkMaster. Furthermore, where the most NES services can inquire about the desired instance directly of each device is in the ring is not defined in the most specification and thus is neither used nor supported by version 3.x. Such procedures of data sender MNS to send a message using the application message service target address 0 equal to 00 first selection process local decentralized registry search field second searching process central registry but not local search field report error such successful it goes to complete transmission. Figure 9.9 shows an example of data sampling. Track 10 in the CD changer, CDC is to be selected via the HMI. The CD changer application is represented on the device with the Uplatz CD, instant ID and colon 1. To change the track, the HMI sends the control message cd.1.track.check10. The HMI application gives command 0ff xff.cd.1.track.check10 to the address handler, which replaces the wildcard 0xFF with the target address of the CD changer according to the procedure explained above. The most network interface controller automatically adds a source address and sends a message to the CD changer. The most network interface controller of the CD changer sends the message onto the most services. The CMD module calls the function for changing the property track in the block CD. Figure 9.8 shows the general syntax of the control message on its way from the sender to the receiver. NetworkMaster shadow module. The NetworkMaster shadow module provides a copy of the properties of the NetworkMaster. It reacts to the status and result messages and is usually implemented on all devices except the NetworkMaster. The basic functions are managing property, NetworkMaster.configuration during the initializing, procedure managing property. NetworkMasters are essentially distributing the address search procedure of the address handler. Example of the address handling according to MOST 2.5 and MOST 2.0. Device 1, MOST network interface controller, CD.1 set 0. Device the D2, HMI controller application, block ID, instant ID, FKT ID up to PDK parameters, FFFF. cd.1.track.10 net services AH, NWS, AMS, device D2, block ID, instant ID, FKT ID, type parameters, CD track 1, set 10, block ID, instant ID, FKT ID, update parameter, CD slave application, block CD, instant ID 1, net services, CMD, AMS, most network interface controller. NetBlock MP. The NetBlock MP is a system NetBlock which must be implemented on all devices. It is thus part of the most NET services layer 2. It was already introduced in section 4.3.4 due to the fact that a minimum NetBlock NBMin is already integrated in the INIC. Only the NetBlock ESC, NBESC of the NetBlock in layer 2 version 2.x or 3.x is implemented. The FBlock enhanced testability ET. The FBlock enhanced testability is a system of FBlock as well and is also described in section 4.3.4. Integration of the most NET services onto the target platform. The most NET services were written in ANSI without using any standard libraries and can thus very easily be ported onto the target platform. The configuration and adaptation for the hardware and software platform use is affected by a compiler such as the other files are just star.h. This enables a good scaling onto the processor architecture. The most NET services can be implemented on an 8-bit microcontroller with only a few kilobytes RAM in the main loop architecture, or also on a 32-bit microcontroller with adequate multitasking software systems such as QNX, WinCE, or Linux. The low-level driver shown in Figure 9.3 and 9.4 must be implemented by the user. The LLD is used for the abstraction of the hardware with regard to the most NET services. The two system-on-chip controllers, OS 8805 and OS 88558, are an exception. In this case, the most NIC and the OS controller are integrated on one chip. Most NET services only need to be configured by the user. Callback function, the largest part of the most NET services provide callback functions for the status and error messages. These functions are made available to the programmer and are called by the most NET services if a specific event or an error has occurred. Callback declaration of function. The callback functions are characterized in the most NET services documentation by keyword callback. The most NET services offer different types of callback functions for the various versions. I see. Most necessary is a layered pointex. In the most necessary layer on pointex, specific callback functions of the type A and B, even though the type A functions must be defined by the programmer, the function body can remain empty if the event which calls the function is not relevant for the application. Type A functions, however, must always be implemented completely since they are responsible for system relevant events such as power on. Most NAS services layer 1, 2.x and 3.x. In the case of most NAS services layer 1, 2.x, the callback functions for unused events do not have to be declared. The most NAS services ensure a defined behavior. It is differentiated between model specific standard callback and general standard callback functions. The model specific standard callback functions are called for a specific event by only one module. The general standard callback functions are what can be called by several modules. They usually indicate the result of interactions with the network interface. Most net services layer 2, 1.x, 2.x, 3.x, like the most net services layer 1, layer 2 also defines a type A and type B functions. Additionally, the versions 1.x and 2.x define type C functions. The type B functions must be explicitly activated by the programmer in the header file adjust star.h. Main loop architecture on the small processor with the multitasking system software, all applications and services except the interrupt service routines are usually called cyclically from a loop in the main function of the software. A programmer must ensure that for all applications and services, the maximum response time until the next call of the central entry function is observed and that the maximum execution time until the next return to the main loop is not exceeded. For the most services provided, the cyclical call of the services must be within 15 milliseconds and other central functions of the MSP, such as checking the log status and the similar operations can no longer be assured to meet the most specification. The maximum return time is typically less than 1 millisecond unless the most services callback functions of the applications on that part. In that case, the application program is responsible for ensuring a return into the most services and thus into the main loop within the required time. For the most necessary services 2.x and 3.x, the problems are easier to handle because all the time critical functions are taken over by the INIC itself, and the most necessary services running on the host basically only form the interface with the application software. The maximum response time also has to be observed in this case, particularly because the INIC supervises the communication with the host by means of a watchdog timer, which is typically configured to a second. If the INIC does not receive a response from the host within this time, it assumes an error and disconnects the host from the network. This results in all application networks provided by the device in the network being unregistered. In addition to the main entry functions on the most net services in the main loop, other functions have to be called which provides the most net services with the information so as to the timing. They are also usually triggered by the timer control interrupt service routine, MOSTT timer init in version 1.6. If all frequencies of 1, 10, and 25 milliseconds can be selected, the most services 2.x and 2.6 have an advanced timer implementation that supports more flexible frequencies, which uses the timing information provided by the INIC. Multitasking architecture, the item mentioned above can also be applied to multitasking architecture. The main loop is, however, replaced by a task loop. Usually, the most net services run in a loop, which, apart from the entry functions mentioned above, only calls functions necessary for communication with other tasks or drivers. Functions for serving other services and applications are typically integrated in the additional tasks. For the most net services tasks, the priority must be selected such that the minimum call frequency of the most net services 1.x can be guaranteed. Higher priorities will generally only be reserved for the tasks with a real-time functionality such as audio, video, signal processing timer, or for network drivers with high timing requirements such as CAN network driver stack. The actual application should normally run in tasks with a lower priority. Due to the fact that the most services are in NCC, they are not thread safe. This means that the API functions may only be called from one context. This means that the handler function of the CMD model must be called and the data must be accessed in the context of the most services task and not in the context of the respective application. The programmer must solve this problem by using suitable synchronization mechanisms of the system software such as semaphores. For this purpose, the most necessary conjunction provides macros in the configuration files, which can be assigned to platform-specific mutex mechanisms, mutual exclusion. For larger system with several applications, one could imagine using instead of central command interpreter an architecture which processes the message received from the AMS and the MOSI protocol through cross borders. One could also imagine executing the evaluation of the messages also a function of the CMD module in the context of the respective application tasks. Such architecture are also available with third-party providers. System management module. Modules such as the NetworkMaster, Power Master, and Connection Master are not part of the most services. They can be licensed as reference implementations with the SMSC in the same manner as the most services. In contrast to the most services, our implementations of the device manufacturer are also commonly used here. Thank you.